So I'm going to talk about WebAudio Modules 2.0. It's like a VST for the web, okay? WebAudio plugins. And I am Michel Buffa, professor, researcher at the University Côte d'Azur in the south of France, near the city of Nice on the French Riviera. And I belong to a research group called WIMMICS that is common to two laboratories in France, INRIA and I3S from CNRS. But I am also involved with the W3C, the World Wide Web Consortium, that is making web standards. So I participated to the creation of some parts of HTML5 in the past. And since 2014, I joined the WebAudio working group that is making the WebAudio API that I'm going to present, and on top of which we built the WebAudio module standard. So what is a working group? It's a small group of people from Mozilla, from Google, from Ableton, from companies like that are just having a video conference every 2 weeks, discussing, writing some specifications. Then there are some implementations in the browser. We are testing them and so on. And we also work with some community groups, people that are not W3C members, but that can help and give feedback and so on. So the work I'm going to present is about WebAudio modules, and it's a group work. I am not the only one there. So the standard, the WebAudio module standard, has been created in 2015 by Oliver Larkin and Jari Klemola. So they were the ones that started the things, and they made very impressive demos and an incredible work at that time. And since then, some other people joined. Professional developers, amateur developers, academic researchers, PhD students. So I'm just citing a few of them. So maybe you know Stefan Letz from the FAUST language team, Steven Ye from C-Sound. Owen Campbell was at Taipei studio and is now working for Apple and so on. Tom Bird is an independent developer that contributed a lot recently to the standard and so on. So, and also lots of my students contributed too. So WebAudio module, what it is, here are a few examples of what you can find. Most of them are open source and can be downloaded from some of the repository I will show later. You will find guitar amplifier simulators, most of the common effects, flanger, tons of different reverbs, phaser, distortion, overdrive, whatever. Instruments, like a recreation of the Oberheim OBXD, the blue thing on the top right, a recreation of the Casio CZ101, the Yamaha DX7. You will find tons of stuff, samplers, piano rolls, MIDI utilities, and so on. So I will make a lot of live demos, so I'm taking some risk of crash, of course. So the first demos will be different kind of plugins in different kind of hosts to show you the diversity, and that it's not just a one-shot initiative with only 1 or 2 persons. So this is the host you can build from the example repository of the distribution. So this is useful for testing your plugins. And all the plugins on the left here are open source and in the distribution. And they cover different technologies. So some are written in pure JavaScript, some are written with the FAUST domain-specific language and compiled to cross-assembly. Some use TypeScript that is compiled then to JavaScript. Some use C-Sound. We've got a pedal board plugin that has been built with React, you know, and we've got some synthesizer that have been ported from Juice plugins from C++ and cross-compiled. So let me show you a few things. For example, an instrument. So this is a WebAudio module, the MIDI keyboard, and you can connect it to, for example, this plugin here. That is one of the first WAM that has been demonstrated. It's a recreation of the Oberheim OBXD. And we've got WebMIDI now in the most browsers. So you can use also a MIDI keyboard. Or I can show you some effects. For example, this is a recreation of the Marshall GCM 800 amplifier. I've wrote this one. And it works real time with the guitar. for example. Okay, so it's an audio conference, so let's make some sound. Oh, by the way, I should have kept the guitar, so let me just load another plugin. By the way, what you see here is the URI of the plugin. So plugins are like images. You can add them to any web applications. You just load them using the URI. They will come with all the code, the CSS, the HTML, the JavaScript, the WebAssembly, whatever, without any conflict with the other content of the page. So they are self-contained, cannot make any conflicts, and you just load them like very simple object, and you use the connect method to connect them together. I will show you that later. So let's try another effect that has been written using the FAUST language, and then we used a GUI builder directly from the FAUST IDE. This has been created in less than 1 minute. With the clock, you can check that. So, for example, this is a port of the famous stone phaser. And you can adjust all the parameters, but what is interesting is that this host also shows all the exposed parameters, and you can try automation. So the WebAudio module 2.0 version supports automation, and you can just try the automation here. It's done at the frequency rate, A rate. So let's try that, for example. And I don't really know which one, the LFO, yes. I just animated this one. So check the knob here. You will see it move in real time. Oh, okay, it was too fast. I didn't have time. But we support automation, and the framework has been optimized a lot with really performance in mind. So we are doing all these things inside the audio thread using shared array buffers and ring buffers and things like that. So we made some tests with up to 300 different parameters animated at the frequency rate, and it holds. So you can have also, let me show you some other demos. Oh yes, some instruments too written in FAUST. So you find thousands of examples of the FAUST language, either from the IDE itself or from the FAUST distribution, and you can find many open source repos with FAUST. Let me select it. Okay. So this is a recreation of a flute. What is interesting is that the GUI has been generated automatically from the FAUST code. I will show that to you later. Once I showed this one, the GUI was made using a GUI builder for customizing it. So these are the things you can do. Let me show you other demos. So this is an open source DAO that is under development, that is made only using WebAudio modules. So it is a WebAudio module host designed especially for that. It is already on GitHub, but it's an open source stuff. So I can load some multi-track songs. Oh, what's happening? Yes. Okay, so this is something. Okay, let's add some plugins. So I'm just loading a set of plugins. The plugins are just, well, the thumbnails, the images are downloaded in real time from remote servers that are not on the same domain as the DAO. So here I can, for example, add the phaser you saw earlier. I can make a chain of plugins. Can add a delay too. It's going to be ugly, but okay, you see, so you can change the order and so on. And here I mixed plugins written in JavaScript, in FAUST, with WebAssembly, using different technologies, written by different people. And of course, you can find the automation here. And what is interesting is that when you add more plugins, the plugins here are assembled in what we call the WAM group, so that they can expose all their parameters at once, send messages to the host. So here I've got more parameters that I can automate. than usual. So for example, if I do the same thing as before, with, I don't know where the LFO is now. Okay, stereo phase, let's try this. Okay, okay, it didn't work. Sorry. Let me go on. So this is another host where you can just drag and drop plugins. This one is not yet compatible with the very last version, but we've got tons of plugins here. So I can try something like that. I can add a delay, and yeah, I can assemble that. Let me just try to do it. So I zoom. Oh, sorry. Yes, let's assemble these things. Oh, yes. Let me try that. Yes, and if I activate the input, should work. Yes, it works. So in that case, this is another example of FAUST where you can build a preset. Well, this one is a bit ugly. Let's try. Okay. So this is a one other host. We've got a very interesting host that has been developed by Tom Burns, an independent developer, that is a mix of Ableton Live and Google Docs. So it's a synchronous multi-participant sequencer where everybody can just share the URL and start adding plugins, making music. And if I'm moving knobs on my screen, it moves also on yours. And let me show you a demo of that. So it's free. You can just log to the place. Okay, let's try it. Play. Oh, I think one of the tracks is not connected. This one is using a sampler, so I need to connect this one to the audio output. No, track output. I don't know why. Oh, okay, it's the other one that is not connected, sorry. The last plugin is not connected to the output. And what you can see here, yeah, should be better. No? No, I don't know, maybe this one. Oh yeah, okay. What is interesting here is that you've got very different kind of plugins, including a plugin that is doing some WebGL animation in sync with the sound. So the WebAudio Module 2.0 framework has some extension for also doing WebGL, GLSL stuff, and you can connect any parameters from the audio plugins or even the audio output to any of the parameters from there. So this is a recreation of an old Winamp plugin that you might recognize. And I can double-click and add any effect or instrument. For example, I want to add a fuzz somewhere. I just click and the fuzz is loaded. Or the stone phaser that I showed you earlier. Everything is just loaded dynamically on the fly. So let me, yeah, it was this one. So yeah. Yeah, oh, okay, it's not the same, the GUI, but it was the same plugin. So you can see, get an idea of what you can do. This is an example in a commercial DAW called Amped Studio. I recorded this 2 days before at my hotel room. So I hope the network is okay because I separated the instruments from I Love Rock and Roll, removed the guitar, and recorded my guitar on top of it, and used a plugin that I wrote that is now included and commercialized by my lab. This one is included in Amped Studio. So yeah, okay. While it's loading, I can just add another plugin that I wrote that you saw also in a previous demo. So for example, I'm adding this in a chain. Okay, it doesn't want to load, so the network is a bit slow for these big waves files. Let's give it a try. Yes, come on. Okay, by the way, Amped Studio is one of the 4 or 5 DAWs that are available now on the web. So you've got Soundtrap that belongs to Spotify. You've got Bandelab that is a Singaporean company. You've got Arpeggio.com and you've got Amped Studio. And we started to demonstrate this web audio module standard to these DAW vendors. So I've got screenshots of web audio modules in Soundtrap.io. I remember Andrew McPherson coded that during a conference and show me that it worked. But it's more decision by the managers and so on. Are we opening to third-party developers or not, and whatever. So okay, it loaded. So you can hear the dry track. So this is what I recorded. Okay, not so good, but let's listen to it now with the effects and the backing track. So you get the idea. So yes, we can make DAWs that work, that you can really use. And with the COVID lockdown, a lot of people started to use such application. One of my PhD students, Xiong Ren, is developing a Max MSP on the web, a patch share. So this is a patch he made yesterday for the conference. So you can directly load web audio modules in the patch shares, and then you can, okay, I need to activate the audio. So the spectrogram is also a web audio module that is a free. Quite psychedelic, and you can add dynamically any web audio modules in the patcher. So let's go to another demo. You can also have plugins that act as host. So you can have rack plugins that with presets, for example. So this one is also freely available with the distribution. Actually, we've got two of them. The second one is written using React, and the first one is plain JavaScript. So here, this is a plugin, and I can load some presets, and there are plenty of plugins bundled in it that are also available, and I can show that here we've got very strange sounds, like this activate the guitar. Yeah, okay. Well, you got the idea. And yes, we like to put WebGL everywhere for animating waveforms. And what is interesting is that this plugin is responsive, so you can also see it directly in a DAW. So the one I showed earlier here was actually the rack plugin. So I can load it here. And what you see, add pedal, yes, I need to select first a track. What you see is the same plugin, but displayed here. So what you've got here is exactly, all these parts at the bottom is exactly the same code without changing any line. Just the CSS is responsive and detects the zone where it is added, and you can start working with it, load some presets and so on. So now I'm going to go a little bit deeper and tell you how you can start using developing. So a few reminders. The WebAudio API has been first designed with an audio graph in mind. So you assemble nodes. Okay, each node is a gain, a filter, a wave shaper, whatever. And some nodes can be source. sound sources, audio sources like oscillators, or it can be a buffer source, so an audio file loaded in memory and decoded. And it can also be a stream like the input of my sound card and so on. And the sound is being processed from left to right. And you build the graph in JavaScript by creating nodes, create gain, create delay, and so on. And you assemble them using the connect method. So some of the plugins that I showed, for example, the guitar amplifier, one of them has been written only using something like 50 nodes like that, finely tuned. And some others are just one node with some WebAssembly inside. So since 2018, the WebAudio API supports also custom DSP code in something called an Audioworklet. So an Audioworklet is the left part is a node you can connect to the graph, and the right side, the green side, is called the processor, and the processor is where the DSP processing is being done. And here you can load some WebAssembly modules. This is how it works. So you've got different approaches that are then possible, because you can cross-compile C++, FAUST, C sound, and yesterday we saw the C major code directly to WebAssembly. So this is the idea, and in the blue part is coded in JavaScript and deals with the GUI and so on. So let's talk now about web audio development. So it's a mix between web developers and audio developers, web development and audio development. So on the web, we've got tons of tools that are used by developers, I mean JavaScript, TypeScript developers, and so on. So we've got building tools, minifiers, NPM modules, frameworks, front-end frameworks like React, and so on. So it's a bit of a mess, because every 6 months there is something new that you didn't know, and that is pretendly better than what existed before. The audio developers are more keen to use C++, Rust, domain-specific languages like FAUST, C sound, C major, patchers like Max, and so on. And when they want to share to make some reusable code, they rely on plugin frameworks such as VST, Audio Unit, Juice, iPlug, and whatever. So we wanted to be appealing to all these kind of developers. So how can we combine this? So I told you already that in 2015, this was the first WAM proposal, and Oliver Larkin and Jari Klemola, they wanted to attract first native developers. They were native developers. So they've been working and showed very impressive stuff on the WebAudio module website. It's mainly instruments, but you can find a recreation of the Yamaha DX7. It's a port of the WebDexed VST plugin. I showed already the OBXD, that is a port of a Juice plugin. Okay, and I talked also about the Casio CZ101. So yes, they made really incredible work in that time. But it was mainly running in one single node, an Audioworklet node, with some ASM.js, but now this has been replaced by WebAssembly. So in 2018, I formed a group of developers and academics, and we enlarged this proposal, and we started to support also plugins that, instead of being just one single Audioworklet node with WebAssembly code, could also be written using a graph of different WebAudio nodes. And so we used a composite class, well, to pack this as a single standard node. So you can load a plugin and connect it like any standard node. And we also started to work with the FAUST team, the guys that created the FAUST language, to help generating rapidly some WebAudio modules. So this was a version from 2018 of the pedal board, one of the pedal board I showed, the one with cables, where you can see plugins written in JavaScript, plugins written in FAUST, plugins written in C++, all connected together, working together. So what's new is that thanks to the COVID and the lockdown, we were all a bit at home for a long time. So we started to make some video conferencing every week with some colleagues, and we decided to renew the WebAudio module standard, and we created WebAudio modules 2.0. Well, let me remind you that each plugin is just a single URI, and now it can be loaded just like any JavaScript module. Import, blah, 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 and you can do this dynamically. So you can just do an import, you get an object. From the object, you say, get me the audio node, and you connect it. Get me the GUI, and you display it. And that's all. In case of MIDI plugins, we've got a different method for connecting that allows to send events from plugins to plugins. So a WAM, as I said, can be made of a single Audioworklet node or made of multiple nodes, so you can have very hybrid approaches. Plugin parameters are handled by something called the paramanager for the automation. And with performance in mind, ring buffer, audio thread isolation, and so on. And you can work with any development chain. I mean, you want to do plain JavaScript, HTML, CSS, do Ctrl+S, reload, it works. You can do some, you can develop like this, or you can use build system with a Webpack, Parcel, Rollup, or whatever. You can use frameworks, so we've got examples with React, and so on. You can write your plugins in C, C++, cross-compile. It's a more complicated chain, development chain, but you can do it. And support for DSL, especially for FAUST, is really advanced. I will show you this in a demo later. And we had Steven here from C-Sound that also showed that you can make plugins with C-Sound. It's got MIDI support. And what is interesting is that we separated the SDK from an abstract API. So if you're a pro developer, you can just make a connector to this API without reusing the parameter automation we are providing and so on, if you already have this. I talked with the developer from C Major yesterday. Their plugins are already using a web-based GUI, and they already managed to produce some WebAssembly code. So I talked to them and said, please just try to be compatible with the API. It's just maybe 10 methods to adapt, and you will be compatible with SWAMs, and you'll be able to load any of your plugins into our host. So how to start with WAMs? Well, we've got 4 GitHub repos. One of them is wam-examples with lots of examples. It corresponds to the first demo I showed when I clicked on the button to load the plugins. The API is just the abstract classes, and then the SDK and the SDK param-manager are reference implementations of the API. If you want to start without too much hustle, you will start using the 2 SDKs, inherit classes, and work from that. So the WebAudioModule.org website, for stupid reasons, is not up to date, because it's a WordPress website that is no more supported by the host, and Yari Klemola promised to work on it. It should soon have a section about the new version of WAMs. So for the moment, it's better to start with the github.com WebAudio Modules channel. And well, everything is under MIT Page 2.0 open source license. And it's also available as NPM modules if you prefer to do NPM install instead of git clone, and if you don't need all the source code. So having the API separated from the SDK, as I told, it's interesting for developers. You can choose to adapt directly their existing code, and the others can use directly the SDK. And the SDK is in 2 parts, and the second part is not mandatory to use, but if you want to benefit from a parameter automation, in particular, if your plugin is made of an audio graph, because when you get an audio graph, each node has its own set of parameters. And what you see on the GUI here are the exposed parameters. So for example, the mix parameter, the dry-wet mix, actually changes 2 parameters in the audio node inside the graph. So if you want to automate this exposed mix parameter, then internally you will have to change 2 different gains. So this is done automatically by the param manager SDK that will allow you to do parameter mapping between the exposed ones and the internal ones. Also, it provides a composite node class. You just inherit from that, and your plugin will be seen as just a single node with a connect method. Okay, so the WAM example repository, when you clone it and you build it, and you can do a start on it. It will show this web page, exactly the one I showed earlier, that is also hosted for the public. And all the examples are open source. You can look at them, they are commented, and this is a very good start. We've got also step-by-step tutorials. If you want to, for example, if you want to learn how to just make a simple host, I want to load, to have an audio player, display the waveform, and just start playing it through a plugin chain. Then you've got all the explanations here with source code, the GitHub repo you can clone, and so on. So let me show you that. Okay, so, and we've got other demos showing how to do automation, how to connect a MIDI keyboard to an instrument, how to connect a piano roll. The piano roll is interesting because it uses some different kind of events called the WAM transport event between the host and the instrument. Start, yes. No? Yeah. Okay, so I should have. Okay, so we've got 7 tutorials so far, but we are adding more all the time. Also, we have a WAM community repo with nearly 100 of plugins inside. So the WAM community repo, well, you can click on it. It's been used for you to reuse existing plugins from the community. So we've got plenty of plugins here. Did I click? Yes, you got plenty of plugins for different contributors. But what is interesting is that it comes also with a README how to add your own plugins. So you clone the repo, you make a new branch, you add your plugin, then you make a PR, a pull request, and then it can be added and benefit the whole community. And it is also online on a server. So that some host can query directly the server, like the one I showed earlier. Yes, okay. When I double click here, the menu that is that appeared here is just a JSON file retrieved from this remote server that exposes all the plugins from the community here. So all the things that are here, the definitions are coming from the JSON descriptors of the plugins from this repo. They are ready to use. Some of the plugins in this repo are built. That means that you don't have necessarily the source code, but the source code is on another repo. Okay, they are ready to use. They're out of the box. You take the plugin, you import it, you put it in your host or in your web page, your web application, and it works. Okay, so. The last demo will be how to build in 1 minute some web audio modules using the FAUST language. So the FAUST language is a domain-specific language for building DSP code that can export to a lot of targets like C major, VST, audio units, and whatever, even for embedded system, and also to WebAssembly and WAMs. So let me show you some demo. So you can grab some FAUST source code. There are plenty of code on different resource pages. And then you load your code here, you run it. Okay, it generates a default GUI that you can use as a WAM also. I showed the flute like that. But you can also try directly your plugin. Yeah, it should work. Yeah. Okay, let's say I like it. Okay, I want to add it to my host, and I want to fine-tune the GUI, but I would like to start with something that is well, more HTML and so on and so on. So you've got a GUI builder here. I will try to do something very rapidly. So yes, let me just change a few things. Remove this this border, maybe, I don't know. Okay, add a texture, change the, okay, I'm stressing, so this is a, okay, let me try to do it better. Okay, so you can choose the knob models. You can, I try to remove this thing, yes, hide component, yeah, I don't want this one. Yeah, okay, so let's put some buttons here, some labels. Okay, I'm doing my best not to make something too horrible. Okay, so you get the ID, so you can select the labels, change the fonts. Let's take something like that. Yeah, okay. So you can adjust the size of the width, okay, of this thing. Oop. Yes, okay. Okay, you got the ID, you can change the colors, make some gradients, transparency, whatever. Tube screamer, yes, okay. Okay. And now you can publish it. So when you click publish, it is already compiled in WebAssembly, published on a website, and you can try it. And you can also see it on a web page because it's published on a server. And from here, you got the URI of the plugin, and you can try it into another host. Yes, one of the I already showed. So if I cut and paste here the URI load plugin, you got it here. Okay, so it's already runnable. Available, you can edit the HTML, the CSS, fine-tune the GUI, add some visualization and whatever. So it took me maybe more than 1 minute because I stressed, but it works. So this is a Google Doc I gave to my students, my master students. I'm giving you lots of first source code. Please make me some plugins, and this is the plugins they created using this UI builder. Sometimes fine-tuning it a little bit, and well, let me just try. Okay, so yeah, so you can find dozens of plugins that have been created this way. And we've got a huge list of things to do for the next months because there are tons of first code available. So I am done. So the WAM standard is quite stable now and comes with many examples that you could see. Our main concerns is get input from you in the audience and from developers. We are on the Slack channel here on the WebAudio Slack channel, sub-channel WebAudio modules. You can reach us. And we would like to get inputs regarding barriers to entry and adoption. Why are you hesitating to jump in this train and come with us developing and using WebAudio modules? So I've got some ideas. So I'm here for making evangelization, as you could guess. And also a lot of things are coming soon. So the WAM community repo is growing. We will have more plugins. We have more plugins every month. It has been extended to support 3D, so we need to have more examples of that. A WAM-based DAW, an open source one, is under development. And we are working on some examples that show how you can port a VST plugin from C++ to WASM. Well, that's it. I finished. Thank you very much.